6 months ago, I invited some of the biggest heat pump installers to survey my home for a heat pump. This included Octopus Energy, who are now the largest energy supplier in the UK, with over 10 million customers globally, and are renowned for their tech-driven innovation. Despite this monumental growth, their customer satisfaction score is consistently highlighted for exceptional customer service, having been a Which recommended provider for 8 consecutive years. In this video, I'll go through my heat pump survey experience, how heat loss overestimation, unnecessary disruption, and rigid protocol, to name a few, meant I chose not to go with Octopus Energy and opted for a revolutionary Heat Geek heat pump install instead, for less than a third of the price. By the end, you'll be prepared with everything you need to know when getting or interpreting a heat pump survey from any company. Welcome back to the channel. My name's Shan, and for over a decade I've been actively building my energy assets, boosting my energy security, all whilst cutting down my bills. If you watched my last video, you'll know we're a family of 6 living in our 5-bedroom detached house built in 1999 in the northeast of England, who had a heat pump fitted earlier this year. Before this, we had a 26-year-old Potterton Suprema 70 non-condensing gas boiler, which had an efficiency of around 76%. We have 370mm of loft insulation, cavity wall insulation, double glazing, and a 300-litre unvented hot water cylinder in our loft, which replaced our 180 vented hot water tank in this airing cupboard on the first floor 2 years ago. A heat pump really would help us get closer to our objective of reducing our energy bills and carbon footprint. After working out my predicted savings in this video here, I knew it was financially viable, and so I wanted to get some heat pump surveys in. Like any big home improvement, I got 3 quotes from Octopus Energy, E.On, and finally Heat Geek via their elite installer Green Home Heating in the northeast of England. Before I go any further, a quick note on E.On, because they dropped out of the running quite early for me. Their initial quote was eye-wateringly high, nearly double what Octopus quoted, and even after the survey, there were still thousands more than Heat Geek. I also had to chase them for crucial details like their predicted efficiency, and in my experience, if you can't get clear information at this stage, it doesn't give you confidence what comes after. So for my home, E.On just didn't stack up, which left Octopus and Heat Geek as the 2 real contenders. Just to say, this is not a sponsored video by any of the companies I mentioned, but rather I'm sharing my journey and experience into the world of heat pumps, and all the views expressed in this video are my own. I too, like you may be, was unsure about the viability of a heat pump in my home. The noise, the disruption, the cost, and what if it was a massive mistake and I can't go back. But since getting and living with one, I've been blown away by how much misinformation there is out there about heat pumps, led by media headlines, poor installs, and the negative rhetoric. So I want to take this opportunity to share what I've learned from my experience to allow you to make an informed decision of whether a heat pump is right for your home, and what you absolutely need to know when getting a heat pump survey. And if this video is useful, please like it and subscribe to the channel for free. It really helps keep me motivated to continue making videos just like this one, and helps other people find it too. I love what Octopus has done for the energy industry, bringing innovation and green tech to our households, coupled with brilliant customer service. I used to move energy providers every 12 months, but moving to them in 2017 was like a breath of fresh air. So much so, I stayed with them for 8 years, sang their praises, and earmarked them to install my heat pump. So why, after my heat pump survey, did I change my mind? Let's go through the key points that led me to this change one by one. Let's start with the heat loss value. Now, if you're new to heat pumps, this heat loss figure dictates everything. The size of the heat pump, the size of your radiators, your efficiency, and ultimately your running costs once the system is in. Octopus told me at the time of the survey that my heat loss figure was 9.7 kilowatts. And interestingly, the surveyor commented at the time that he thought this might be higher. You can imagine my complete surprise then when Heat Geek calculated this heat loss figure to be 6.7 kilowatts. A massive 30% difference. So why was there such a big disparity between the two? On looking into this further, I learned that it's commonplace for companies to assume a higher heat loss figure when calculating heat pump requirements, and it's largely due to their use of conservative assumptions, simplified or standardized calculation methods, and a desire to avoid undersizing systems, which could lead to complaints about insufficient heating. But why is this a problem? Bigger, after all, is better, isn't it? Not always, and there are several reasons why. Frequent starting and stopping consumes significantly more power than running consistently. which leads to higher utility bills and negates some of the energy-saving benefits of a heat pump. These increased electrical surges and mechanical stress from frequent cycling put excessive strain on internal components, especially the compressor, according to many installers. And this accelerated wear can significantly reduce the unit's expected lifespan. It can also lead to disruptive noise when the unit powers up and shuts down frequently. And of course, larger units cost more to purchase and repair, further adding to the lifetime operating costs of the system. So with that higher heat loss value, it's no surprise that Octopus recommended an 11 kilowatt Daikin heat pump. Heat Geek, on the other hand, suggested a 7 kilowatt Valent Aerotherm Plus heat pump. Okay, what about the radiators? I was expecting some changes here, as that's what you do when you get a heat pump, right? Octopus met my expectation, specifying 16 radiator changes were needed throughout the property. So you can imagine my absolute disbelief when Heat Geek said I didn't need a single radiator change. Okay, just hang on, if I wasn't uncertain enough before, by this point I'm completely lost, and more explanation was needed. Octopus's recommendation for 16 new radiators likely stemmed from a more traditional or conservative design approach common in the heat pump industry. To guarantee the system works even on the coldest days, many standard methods use safety factors in calculations, which often result in an oversized system and the need for larger radiators. Standard heat pump installations might be designed to run at higher flow temperatures, for example 50 degrees Celsius, which requires larger radiator surface areas to achieve the same heat output as a boiler would at 70 degrees. Recommending new, larger radiators is a straightforward way to ensure sufficient heat output across various housing stock conditions, minimizing potential callbacks for an underperforming system. But this of course increases upfront cost and disruption. On the other hand, Heat Geek used a digital platform involving LiDAR scans and AI-powered design software to precisely measure my home's actual heat loss room by room, avoiding guesswork. This process essentially automates and perfects what is known in the industry as the manual J-load calculation, which is the engineering standard for determining exactly how much heating a building needs. This prevents the overspecking that leads to unnecessary and costly upgrades. The system design uses these results to achieve an efficient flow temperature that works with your existing radiator size and pipework by optimizing flow rates and using weather compensation. The design considers the house as a complete thermal system, based on the total calculated load, not just individual components. And it's this detailed analysis that allows the installer to potentially reuse existing radiators and pipework where compatible. Now, what about the hot water tank? As I mentioned earlier in the video, we had a 300-litre unvented hot water cylinder installed in our loft, which 2 years ago replaced the 180-litre vented hot water tank in this airing cupboard on the first floor. With this being a relatively newly installed hot water tank at a cost of just over £3,000, I really didn't want to have to replace this again, and I fully expected this to be the last thing that needed to be changed. However, this is where we ran into major conflict. Our existing hot water tank, whilst being super insulated, only had a standard coil size of 0.97 square meters, which is typically used with a gas boiler. Octopus, during our survey, recommended we replace this almost new tank, advising us a coil size of 2 to 3 square meters is needed. A massive coil surface area is often advised because heat pumps operate at much lower water temperatures than a traditional gas boiler, meaning longer reheat times. The larger coil compensates for that smaller temperature difference to heat the water up in time, so it made sense what they were suggesting. In our experience though, we would often use our old gas boiler twice a day, morning and night, to heat the hot water we would then store in the tank to last the whole day. So a few hours of reheat time I didn't really see to be an issue for our home. And to make matters worse, Octopus told me they didn't have a 300-litre slimline tank they could supply to replace the cylinder in the loft. Instead, they advised the tank would need to go back in the airing cupboard. But where would I now store all my kids' junk? It seems to me that Octopus essentially work with a standard kit of parts. Their heat pump compatible cylinders are typically large, vertical, and require a certain minimum depth, which our airing cupboard didn't have and so couldn't go in there. Because we couldn't make their standard kit work in our existing space, their only suggestion was to relocate the hot water tank to our utility room. This would have meant moving our washing machine and tumble dryer upstairs into the airing cupboard, a solution we weren't keen on at all. To be fair to the surveyor, who was friendly and knowledgeable throughout, he acknowledged this was a less than ideal scenario, but at least this option allowed him to complete the survey report. Enter Heat Geek, who looked at the same tank and said, "No, you're fine, we can keep it." The look of relief on my face at this point must have said it all. I mean, it would have meant £3,000 down the drain if it couldn't be used. Heat Geek's Zero Disrupt method means they wanted to optimize everything around my home's existing system. By using precision engineering and weather compensation controls, they can slow down the flow of water and manage the heat saturation point to make my smaller coil work efficiently with the heat pump. This was a massive cost and disruption saving for us. Okay, so what about the expected SCOP? Time for Octopus to level things up here. The most important number to understand when installing a heat pump is the SCOP, the seasonal coefficient of performance. It's simply how efficiently your pump runs over an entire heating season. Octopus gave me a predicted SCOP of 3.56. That sounds great, but it's only meaningful when you know what it's based upon. Octopus's SCOP prediction of 3.56 was calculated with a flow temperature of 50 degrees Celsius, 18 degrees Celsius for bedrooms and hallways, and 21 degrees Celsius for all other rooms, and based on an outside temperature of minus 3.4 degrees Celsius. But what about Heat Geek? Their SCOP is a guaranteed minimum of 3.43 based on a flow temperature of 50.2 degrees Celsius, room temperatures at a cozy 21 degrees Celsius, and outside temperature of minus 4 degrees Celsius. So a win for Octopus with their SCOP of 3.56 compared to Heat Geek's 3.43. But not so fast. As a naive homeowner, I assumed the SCOP figure represented the efficiency for both my central heating and hot water. But it doesn't. The SCOP quoted only measures how efficiently a heat pump provides central heating. It doesn't include the hot water production at all. But why is this important? Well, hot water heating is often the least efficient part of your heat pump system, sometimes running at a SCOP of just 2.5 to 3. So our Octopus expected SCOP of 3.56 looks very different now. Furthermore, it's not even guaranteed. So if it falls below this figure, there's nothing you can do about it. This is from our heat pump survey report. Our standard installation includes all radiator changes if needed, required to meet our design standard, which is to achieve a minimum seasonal coefficient of performance, SCOP, of 2.8. This meets the off-gem design requirements to redeem the bus grounds. In contrast, Heat Geek quoted a minimum whole system efficiency, i.e. including central heating and hot water heating, with a SCOP of 3.43 or 343% efficiency. And Heat Geek will guarantee this minimum efficiency figure for 5 years, which is a sign of confidence in their system's real-world efficiency. This is provided you follow Heat Geek's best standards to practice for controlling your system, outlined in their terms and conditions, which can be found on their website. What about after the installation? At the time of my survey, both Octopus and Heat Geek offered a 2-year workmanship warranty. The Dakin and Valent heat pumps come with a 5-year and 7-year warranty, respectively. Note all Octopus Cozy heat pumps come with a massive 8-year warranty. Octopus offers 7-day-a-week post-installation support, and for Heat Geek, support is via your heat pump installer. Now on to servicing, which is required to keep those warranties that we talked about going. With our old gas boiler, we used to pay around £80 a year to have it serviced. With an Octopus Energy heat pump, their basic service plan covers the annual full system service and all these other bits for only £9 a month, which works out at £108 a year, which is just brilliant value. From what I understand, a Heat Geek would typically charge between £150 to £250 for a heat pump service. That's over 3 times the price compared to my annual gas boiler service, which had more moving parts and therefore more to go wrong. So why is it so expensive to service compared to a gas boiler, especially for Heat Geek? I reached out to Adam Chapman from Heat Geek to ask him that exact question, and he replied, currently Heat Geek umbrella service companies do not offer a service package. So servicing is either dealt with directly by the engineer who did your installation, which we would always advise is best, or you're welcome to have it serviced by anyone else. Typical heat pump servicing costs are £150 to £250. Heat Geek are looking to address this and create a service package that becomes more competitive within the next year or two. So it sounds like they are aware servicing costs are high, but the price should hopefully fall soon. So watch this space. Octopus Energy for all the above was quoted to cost us £7,768.24. Heat Geek, on the other hand, via their elite installer Green Home Heating, for all the above would cost us £2,150. How about efficiency then? Let's look at the real world numbers, and I've been tracking every kilowatt hour the heat pump has used for the first 5 months since the install. My Heat Geek installed system achieved a fantastic coefficient of performance (COP) of 4.68, using 1,455 kilowatt hours according to the app. But I wanted to be sure this consumption figure was correct. My installer Green Home Heating fitted a Shelly EM device to monitor this, and it suggested only 1,372 kilowatt hours had been used, generating 6,713.7 kilowatt hours of heat and hot water, giving us a recalculated COP of 4.89. I know what you're thinking. Most of that data encompasses the summer months. Well, here's November's figures, when the temperature dipped below zero. You can see we generated a total of 2,975.2 kilowatt hours of useful heat and hot water, consuming 654.4 kilowatt hours, giving us a very respectable COP of 4.55. With my old gas boiler, this period last year cost me £386. This year, it's cost me just £190.80. That's £195.71 saving, and I went into detail about how this was calculated in this recent video. The best part? It's not only about the money saved. In just over 5 months, this system has saved nearly 800 kilograms of CO2 compared to my old gas boiler, and we saved those 16 perfectly good radiators and my hot water tank from being replaced. And as they say, the greenest products are the ones you don't have to manufacture. We have a massive challenge to decarbonise our energy consumption in the UK, and we need the big players like Octopus to succeed. They have the reach, the visibility, and the resources to shift the whole market. But right now, there's a noticeable gap between what large-scale standardized installations deliver and what highly optimized detail-driven specialists can achieve with less disruption. And honestly, this competition is a good thing. When different approaches push each other, it drives innovation, raises standards, and ultimately benefits us as consumers. And as consumers, we can influence how the industry evolves. Every time we accept a one-size-fits-all solution, every time we replace hardware that might not need replacing, and every time we don't ask for the design detail, we quietly tell the industry that good enough is acceptable. So it's worth asking questions and understanding how the whole system will work in your home, not just the heat pump itself. But here's the point I'm still wrestling with, and I genuinely want your view on. On the one hand, we have the Octopus approach, standardization and speed. They want to install heat pumps with the same consistency and repeatable process you get from McDonald's. Fast, predictable, and scalable enough to decarbonize the country quickly. On the other hand, we have the Heat Geek Zero Disrupt approach. Bespoke efficiency, taking the time to design every system around the home you already have, so running costs stay low and the grid isn't overloaded. Don't get me wrong, both models have strengths. Both move us towards net zero, but which direction is best for the UK right now? Is it more important to install heat pumps quickly, or do we slow down and focus on precision so the long-term costs and carbon savings are maximized? I chose precision for my own home, but what does the country need most? Let me know in the comments section below which one you choose, quantity or quality. I'll be reading through them to see where the community stands. Thanks for watching, don't forget to like and subscribe, and I'll see you in the next one.